Alright, I don't know if I should have bought this or not, but I did. So this is the RF demo kit. And these were 10.89 it looks like. $6.39, and there's like a 5% coupon. You save like 39 cents or something. I think I paid $6.60 or something. $6.62. It doesn't really matter. Anyway, I figure if it's a piece of crap, I'll just send it back. But this will give me the motivation to like actually like start kind of working on stuff. I wanted to be doing more building stuff and stuff like that, and designing circuits. And I've never used that nano VNA to do anything except for check the antenna. So it should be kind of fun. Holy hell, what is this thing? Jeez, it's a lot of money. I've not found an attenuator deal that was suitable. So I'd always seen these before in the past. They were always $9 or $10, $13. Think, why is this $13? Does it come with something else? Why is one $6 and one's $13? Like, it looks the same to me. Did it come with something else? Interesting. So I have some of these little connectors here. I think they came out of a wireless router. They use these on the mesh-tastic things. Just different stuff uses them. So they're usually actually not that big of a deal. I just wouldn't want to have to solder any of them myself. What in the hell? Why is this? Holy moly. Okay, so you get some connectors. Okay, you get two connectors. You get the test connectors that should have came with it, and a coupler and another coupler for $27. This board looks different though. Everything's in a different spot. Interesting. Everything's in a different spot on this one. It doesn't even look right. 400 megahertz low pass filter. So I want to be able to learn how to do and like build like these kind of filters and stuff like that, because by doing that, like, you can learn to build like certain types of antennas and antenna traps and things like that. So I just kind of, I understand the concept. I've just never actually put it into action. So it's a good deal on a nano VNA, $45. Yeah, these are all expensive, like $8. Now, honestly, like, some people were coming, they should send you one of these boards with every single one of these nano VNAs. So here's one that comes with a board, but it's not really a deal. But it's cool they include it. See, I don't understand this. It's a 10 watt attenuator, 10 dB. Okay? If we go and we look in the website, it says for tiny SA. Okay, so Tiny SA has a page. I don't know if this is it. It's probably not. Okay, it's not. It's groups.io. Oops. Let's see. Just some information on here. But there's a page that they have. If I can find it. And you can test the attenuators, I guess. But there's just so much stuff to know here. It's like, wow. 60 dB of attenuation is perfect. 1/1,000,000th of a watt. Alright. But I want to find what I saw earlier. I'm glad I screenshotted it because I can't find it now. And it was really... Okay, main. Safe measurement of the output of transmitters. This is it right here. So this is like answered all my questions I spent reading up on. Calculating dB is not too difficult. Every factor of 10 increases the power of a signal, raises the dB level by plus 10 dB. Every factor of decrease does the opposite. The typical output of a transmitter, 100 watts equals plus 50 dBm. So I guess that's 50 dB milliwatts. And then 10, so basically the output of the transmitter equals 50, the output of a 10 watt equals 40, and a 1 watt equals 30. So this is why I don't understand the purpose of so many of these 10 dB attenuators. So you need to be higher than these numbers, basically. And what it's going to say exactly that down here. For best measurement of harmonics in the output of transmitters, the input level of the tiny SA should aim between -20 dB and -10 dB. Required attenuation between a transmitter and a tiny SA. For 100 watts, between 60 and 70 dB. So what they're doing is they're adding 10 to 20 dB over what's required. And then same thing for 10 watts. So if we were to say 50, we need 70. For 10 watts, it's 40, we need 60. For 1 watt, it's 30, we need 50. You need 50 dB of attenuation and an attenuator that can handle 1 watt just to test a 1 watt radio. So basically, if you want to test any of these Bofang radios that are under 10 watts, you need basically 60 dB of attenuation at 10 watts. And I haven't seen anything really for sale on there like that. I see 10s, 20s, and 30s, and I see people making combinations of them. I just don't like that. The best approach is to always use a 30 dB attenuator directly connected to the tiny SA, and to use power attenuators to reduce the output of the transmitter to target the input level of this 30 dB attenuator. So you will need these power attenuators: 30 to 40 dB, 20 to 30 dB, 10 to 20. So anyway, it's just a really good page here. It gives you lots of information, and there's other stuff here I haven't even gotten into. I'm not going to go the attenuator route right away. I'm going to make a RF sampler, and I probably have enough parts laying around to do that. So indirect coupling, I think, will be much better. I'll even maybe just make a gimmick wire or something. But I've got a couple of little project boxes and stuff like that I need to get into and check that out. So that should be fun to do. And I'll have that. I should have that thing either Friday or Saturday. It depends on what Amazon decides to do. So there's something else I was looking at, and then I need to go and I need to order my I'm gonna order the amplifier kit, the really cheap one, and I'm gonna build it. And it's not really going to be cost effective because you need a heat sink. So I think, like, literally they had ones for like $25. Let's see where we got here. I want location, buy it now, USA only. I might not get very good results. So what I was thinking of doing was if I could find one for like $11, one like this. So this is a kit. This is $25, and it doesn't come with that heat sink. If it did, yeah, I think that would be a good deal. These 30-watt amplifiers do. So $16 right here. This is the cheapest one I've seen so far. So that would probably be okay, because I think it's being shipped from like New York. And this company's got 99.2% positive feedback, which isn't great, but it's pretty good for a seller that sells a lot of stuff. Here is this. This is the 45 watt. I don't really want the 45 watt, but I was thinking maybe I'll build a couple of these. I have a heatsink somewhere. I've got to find it. Let's see. Is this the 45? This is the 45. So even this one I don't really want, because there's some differences on the board, and it doesn't have the part for the low pass. So if you get the other kind, okay, so if you get the 70 watt, so the 70 watt has, I don't know if we can see it. Come on. There's it keeps showing me the wrong thing. On the side here, right here, is an in and out for a low pass filter board. So anyway, I want to do that, and I think that'll be fun. I don't really have a purpose for it, especially if I actually end up returning the X6100, which I might do, might not do. The only reason I might not return it is I really don't want to deal with like the whole return process on Amazon with like, it's not like when you're returning something that's like $20 or $30. They usually treat it differently, and so you're subject to restocking fees and all sorts of weird crap. And to make it go smoothly, I'll need to contact Radio Oddity and see. I don't really, if I keep the radio, I don't think I really want the radio replaced, because I'm pretty sure all the radios have birdies. But I don't, that's what I don't like. I don't like the birdie part. Okay, otherwise I like the radio. I don't care about the QRP thing. I know all about that game. I've had QRP radios. I like the idea that I can grab the thing, it's got the battery in it, and you know, it's portable. And even with the birdies, I like it better than the old Yaesus. So there you go. Anyway, I gotta get some stuff done, and we're gonna try and start on some projects and stuff. So maybe start filming the Game Boy being torn apart. Catch you guys later.